Okay. All right, ladies and gentlemen. What's the derivative for example number 1? F prime of x. What's the derivative of 8x cubed? Using the power rule. 24x squared, right? 8 times 3 is 24. Reduce the exponent by 1. What's the derivative of negative x squared? Minus 2x. The derivative of 5, which is a constant, 0. You don't have to write that down if you don't want to, but I'll just write down 0 so you know. And these things look kind of weird. So a lot of times what I like to do is rewrite them as powers of x, first of all. So I would rewrite them as negative exponents. And then when you write it in that negative exponent form, it's a lot easier to find the derivative. What is the derivative of 2 times x to the negative 1? Negative 2, yeah. Negative 2x to the power of negative 2. Good. And I'll leave it in this negative exponent form for now. And then the last one here would be minus 12x to the negative 4. Okay. Now, if the question asks you to leave things in positive exponents, then you have to change them. But otherwise, just leave it like that. That's fine. Okay, as an extension, I showed you the idea of the second derivative. Remember acceleration? That's the second derivative of the position function. So the notation is f double prime of x. Yeah. Oh, I'm sorry. Yes, up here should be plus 2x. Thanks, Elena. Right? Because I had the negative there, right? Negative times negative is positive. Thank you. Nicely done. Okay, so if I ask you now for the second derivative, that just means take the derivative of f prime of x. So the derivative of the derivative. So let's do this one more time. 24x squared, the derivative of that is just 48x. And then the derivative of negative 2x is just minus 2. That's right. It's the constant multiple rule that we learned. So that coefficient in front, which is the 24, will always be a coefficient. Yep. 2x to the negative 2 becomes negative 4x to the negative 3. And then negative 12 times 4, I believe, is just 48. So 48x to the negative 5. Okay? By the way, that's just the review. Okay? Yes? Well, I have to reduce the exponent by 1. So negative 2x to negative 2 when I take the derivative.
So negative 2 minus 1.
Yeah, right? So 2 parts to the power rule. You bring the exponent down to the front, and then you also reduce the exponent by 1. Yeah. Okay, ladies and gentlemen. Product rule. So when you have two functions being multiplied together, this is the f of x, one function, and g of x, another function. The derivative is not take the derivative of f multiplied by the derivative of g. It's not. Okay? I'm not going to prove it to you now. You can do that later on next year in AP Calculus. But the actual formula to calculate the derivative of a product of two functions is this. H prime of x is the derivative, so it's f of x times g prime of x times f prime of x times g of x. You're thinking, how am I going to memorize that? Ew, you're right. So in words, it says the derivative equals to the first function, that's f of x, multiplied by the derivative of the second function, that's g prime of x, plus the derivative of the first function, which is f prime of x, multiplied by the second function, g of x. That's too hard. So here's what I do. I don't call my functions f of x, g of x. That's a mouthful. I call them a and b. Okay? So what's the derivative going to be equal to then? Well, it's a b prime plus a prime b. You get some rhythm there? A b prime plus a prime b. Okay, rhythm. Get some rhythm. A b prime plus a prime b. No, I have song. This is rhythm now. Okay, it's like rapping. There's no song. It's just rhythm. Feel the beat. Okay, so let's take a look at this example here, please. Example number 2. And I'm going to ask you to find the derivative of this function. You see how it's a multiplication of two things? So let me call this, using product rule, I'll call a x squared minus 3, and I'll call b x cubed plus 5. Okay? Now, we can apply the rule right away, or if you want to organize all your information, I'm going to ask you to quickly find the derivative of both a and b. So let's do the derivative of a, which is a prime first. If a is x squared minus 3, what's the derivative of a? 2x. Yes, Anna, question? That's right. So I'm going to show you that as well and show you that they're the same. Yep. Okay. So later on, Anna's stealing my thunder. She's going to we'll do solution number 2. But anyway, that's okay. B prime, can someone help me out with B prime? 3x squared. Good. So now, here's what I'm going to ask you to do using product rule, right? F prime of x. Here's the rhythm. It's A, B prime plus A prime B. Say it to me. A, B prime plus A prime B. Thanks, that one person who said it with me. So, all you need to do now, since you know all the parts, is just to plug it in. We know A is just x squared minus 3. That's great. We also know B prime is just that 3x squared. Okay? And then we're going to plus A prime, which we also know is 2x, times B, which is just x cubed plus 5. That's great. And then I'm going to ask you to please expand and simplify. So we'll expand this out. 3x to the power of 4 minus 9x squared. And then we have plus and expand out the next part as well. So 2x to the power of 4 plus 10x. And can you please simplify by collecting on the like terms? Yes, Vincent. Okay. You're welcome, Vincent. Oh, okay. 3x to the power of 4 plus 2x to the power of 4 is 5x to the power of 4. And we have here a minus 9x squared. And we have a plus 10x. Agreed?
Do we have to keep, like, derivating that?
No, just once. Right? We did the derivative just once.
Okay.
So we're done. Now, to double check that your answer is right, Anna suggested, well, Mr. Lee, can we just expand the brackets from the original function and then take the derivative? Yes, you can. And that's solution number 2. So I'd like us to try that just to make sure that these two answers are exactly the same. So I'm going to ask you now to actually expand out the function first. So x squared times x cubed is x to the power of 5. X squared times 5 is 5x squared. Negative 3 times x cubed is negative 3x cubed. And then negative 3 times 5 is negative 15. So if you wanted to expand it out first, okay, and then take the derivative, you most certainly can do so as well. So go ahead and take the derivative, and let's hope that this also equals to the box on the left side. What's the derivative of x to the power of 5? Same thing, 5x to the power of 4. What's the derivative of 5x squared? 10x. What's the derivative of negative 3x cubed? Minus 9x squared, and the 15, well, that's just 0. If I were to write that in order of powers that are descending from 4 to 2 to 1, look at that, it's the same thing. Okay? Now, you might be thinking, Mr. Lee, why did we do the product rule when it was so much easier to do the expand and use the power rule? You're right, this one's easier, but we're learning this for the first time, so I want to give you an easy function. Most of the time, these functions are quite nasty. Maybe there's 3 terms or 4 terms, and good luck if you want to try to expand things out. It's not so fun. In general, the product rule is easier when you have 2 functions, okay? All right, so go ahead, please, underneath, as an exercise, can you find the derivative of this function? And I'm going to ask you to please use the product rule. And then for those of you who finish early, you can go ahead and expand and use the power rule to double check. But I think most of you won't. So just go ahead and use the product rule right now, please, okay? I'll get you started by saying let a be equal to 2x cubed plus 6x plus 1, and let b be equal to the function negative x plus 3, okay? I'd suggest you find the derivative of the parts first, and then plug it into the formula. Go ahead and try, please, on your own. So go ahead and find the derivatives, please. So I hope you found the derivatives of the individual pieces, and then you start plugging into the formula, and then expand it out in the end, and simplify. The quotient rule. Okay. Okay. Look how nasty this one looks, all right? Your function is made up of two things, two other functions that are being divided by each other, okay? F is the function on the top, the numerator. G is the function on the bottom, the denominator. So here we go. Just listen first, and then I'll tell you another easy way of doing it, okay? So here it is. H prime of x equals to g of x, the bottom, times f prime of x, the derivative at the top, minus this time, not plus, minus f of x, the top function, times the derivative at the bottom, all over the bottom, g of x, all squared. Good luck trying to memorize that. So, let's do jingle, okay? So, here we go. You know what? Numerator, denominator, whoa, way too many syllables. Okay? Especially with more syllables, that's bad. So, what's another representation for the numerator? How about the word high? Okay? And then how about g of x? Low. Good. All right. Listen first, okay? And then I'll let you write down. Okay? So, don't fail yet. So, g of x, which would be what?
High.
No. G of x is low. Okay, so don't write this down. Just listen. Low. And then f prime of x. So,
Prime high.
prime high. No. So, I should be calling it the derivative, right? Derivative is way too long too, right? Duh a high? No. How about this? D. D stands for derivative, okay? So D high. Okay? So D high, right? D high. D high. So
Wait, why is it D?
D is my interpretation for derivative, because derivative is too many syllables. Okay? Shh. Okay, here we go. Now, what about the minus sign? Minus, too many syllables. No.
Really?
What's another word for take away is even worse. Subtract, no.
All the same Chinese.
Less. Oh, I like less. Okay, good. Low D high.
Wow.
Less. Okay, now f of x would be what? High. And then what's g prime of x? D low. So low D high, less high D low. Good. Okay. So here's your high D low part.
It's just like a bunch of
Okay.
words.
Now, how about the bottom? Now, here we go. G of x all squared. So
Wait, what's less?
you have to make this kind of rhyme, right? Or you're just thinking I'm just memorizing a stupid line. Here we go. Shh, Prativa, listen, okay? So here we go. Low, D high, less high, D low. And here's the bottom part. I say square. Okay, you see that square, right? Square the, and I don't want to use low, because that sounds kind of weird. So I say square the bottom. And of course, that just means low. And then, of course, this doesn't really match up. So low D high, less high D low, square the bottom. And to make it sound good, we'll say, and here we go. Okay? Or, a few years ago, some of my students said, that sounds so dumb. So he said, low D high, less high D low, square the bottom. And then this is what that person suggested. And instead of here we go, and it says, and get the quotient. Get it? Quotient.
Wow.
Yeah, that's what I thought. You know, it wasn't that great either. But so I never really adopted it. So I like the idea of square the bottom and here we go. Okay, now if you don't like the jingle, low D high, less high D low, square the bottom, and here we go. Okay. If you don't like the jingle, go ahead and memorize the formula as g of x times f prime of x minus f of x times g prime of x all over g of x all squared. Like,
Wait,
it's up to you. Okay?
Isn't this just the product rule divided by g of x?
It's not the product rule because look, it's a minus sign. The product rule is a plus sign, so it's very similar to the product rule, but it's not exactly the same. Okay? Anna, question. The order matters here, yes. The product rule doesn't because you're summing, but because this is a minus, the order matters. Kitty.
For the jingle, do you know the bottom is low?
Okay, fine. Square the low then, if you want to call that. Do you want to go square the low, and here we go? Low D high, less high D low, square the, I use bottom, but square the low, and here we go. You can do that too.
Yeah, I'm not.
But you're missing that one syllable, so, you know. Or you can go low, low. I don't know. Like, your choice. Katharina.
Does that mean that like we're not squaring the bottom because it is the one value on the bottom, but because
You're squaring not just the value, you're squaring the entire function. Okay, and I was
when you mark it as high and low, do you mark it by a value or is it one
function, the whole thing. I'll show you an example. Okay. Let me show you an example to try to help you out with this. Okay. Example number 3. Shh. Okay, you guys ready? Richard, seriously, okay? Get her out of here. Here we go. Shh. Hey, seriously, ladies and gentlemen, I'm wasting your time, you're wasting mine, okay? Here we go. So let's take a look at this. This is what I mean. I'm going to talk about this whole function as high, okay? And this entire function down here as the low. So really, high just means numerator, the entire numerator. Low means the entire denominator, okay? No, it's the same thing. Yeah. So here we go. F prime of x. And I'm just going to use my jingle. Here we go. Low. What's low here? It's x plus 4. What's d of high? What's d of high? The derivative of x squared minus 3. What's the derivative of x squared minus 3? 2x. Good. Gia, I can hear you here 2 minutes. Okay. So low d high. What's the next part? No, well, less. Don't forget less. Okay, less. And then we'll do high. So what's high? High is the x squared minus 3. And now what's the derivative or d of low? What's d of x squared, or sorry, x plus 4?
1.
Just 1. Good. So you see, I did low d high, less high d low. And then I'm going to say divided by, right, square the bottom, or the low, whatever you want to call it. So squaring the bottom just means take x plus 4, and we're going to put a square next to it. And here we go. Now, this is the general formula. I'm going to ask you now to simplify. So what I like to do is most of the times I will not simplify the bottom, because you're just squaring things. That's a waste of time. But I will ask you to simplify the numerator. Okay? So we'll simplify the numerator saying 2x cubed plus 8x. And then this minus sign has to be distributed in there. So minus x squared plus 3.
Why is it 2x cubed?
Right, 2x squared. What am I doing? 2x squared. Okay? And then we're dividing that by, and once again, like I said, we will not expand out the bottom. Most math people will understand when you're doing the quotient rule that the bottom can be left as a square. That's perfectly fine. And then if you can just simplify the numerator a little bit more, you'll get x squared plus 8x plus 3. And this is the derivative of that original function, which was a quotient. Okay? And that's it. So I'm just going to ask you to try the exercise to the right. Okay. Once again, you have a function. You can see that it is a quotient because there's something on the top and something on the bottom. And what I'd like you to do is try to do the derivative using the quotient rule or the jingle, whichever one you wish. And let's see if you can calculate the derivative. Okay? And then we'll just do a few more examples and we'll be done today. I'll actually leave you some time. Okay? Double check your answer with mine, please. 3x squared minus 16x plus 12. Is that what you got in the numerator? No? Yes? You got that? Can someone give me some confirmation so I feel good about myself? Okay, yes. All right. Okay, last one. The last exercise. Whoa. This one seems to involve a quotient. Right? Here's your high. And here's your low. And then I got brackets in the high, so that looks like it's product rule. Now, you could just expand this out first, and then treat it as quotient rule only, yes. But I'm going to try to spice it up for you. Hello, Mr. Tadia. Spice it up just for you. Good. Okay.
I know that one.
And then we will spice it up by actually leaving this as a product, okay? All right. Okay, listen up. This will get confusing really fast. Here we go. Okay, low, D, high. Here we go. What's low? X cubed plus 1 times D of high. What's the D of the high? Well, here's the problem. D of high means you have to use the product rule. What? Yes, you do. Okay. Tony, you with me? Okay. Show me that you're with me. So, D of high using the product rule means this. I need my A, I got my B, and then it's A, B prime. So A, B prime is 2x plus, what's the product rule again? A, B prime plus A prime B. Good, so A prime. A prime would be 2. B is just x squared minus 5. So that whole thing in that square bracket is my D high of the low D high. Okay? So all I have once again, low D high. Okay, that's all I've got so far. All right, so low D high, and then of course less, and then here's my high D low. So what's high D low? High is that whole thing there, 2x plus 3, x squared minus 5. There's my high, and then D low. What's my D low? The derivative of x cubed plus 1 is just 3x squared. So once again,
Those three together.
yep,
Why do you have that dot in between them?
multiplication.
Can
Just to
you
show.
Can you just stick them
Yep, you're right. I can stick them together. Let's not confuse you. You're right. Is that better? Is that better, Edison?
Yeah.
Okay. Low, D high, less, high, D low. That's just the numerator. And then don't forget to square the bottom. And here we go. Okay, so obviously I didn't leave enough room, did I? Dot, dot, dot. You simplify at home. Okay? Well, the main part is just knowing how to use the formula, right? You guys know how to simplify by now, so let's not worry about that. Okay? Okay. Once you've done that, one last example, and that'll be it for calculus from me. Okay? I hope that this will give you a good head start to your AP
How
Calculus
many chapters did we get?
BC. We got through about a chapter and a half. Okay?
Oh, dear.
Okay? All right. Last type of derivative question I'll show you. By the way, for those of you writing the AP exam, they love having data in tables. There's always a question or two where they don't give you a function, but they give you numbers in a table, and they ask you to interpret this table. So let me show you what I mean as a quick example. Suppose you have two functions, f of x and g of x, Both of them are differentiable, meaning you can find the derivative at every single point. Okay? However, we don't actually know what the function looks like. All we know are the following things. Okay? All we know is that when x equals to 0, that's this row here, okay? F of 0 equals to 2. So this number here means that I look down the column, it's f of x. I evaluate it at x equals 0. So this really means f of 0 equals to 2. Okay, that's what it means. Okay. This number down here means what? Can someone tell me? F of 2, right? So f of 2 equals to 3. Okay, let me just show you a few more. What do you think this number over here means? Okay, this one here. This is g prime of x, but what's the x value in this case? 0. So this means the derivative of the g function at 0 is equal to negative 10. Okay, and as another sample, this one over here, what does this represent? Just so that you know what this table is talking about. G prime of, but careful, it's not exactly the same. G prime of 2. So we're saying at x equals to 2 on this g function, the derivative is equal to negative 7. Okay, so you get the idea of what the table looks like now. Good. I'm saying to you, by giving you this table, we have enough information to calculate the derivatives at particular values of x. Okay? So we can't actually use the function to help us find the derivative, but we can use these ideas and the table values to calculate the derivative. So let's take a look at part A. If I asked you to find the derivative of 8, which is a constant, multiplied by a function, anyone remember what the derivative should be? A constant times a function. Remember? Back to last day. If I have a constant times a function, it's called the constant multiple rule. What do we do there? That's right, constant times the function's derivative. So leave the constant as is, 8. And what's the derivative of the function? We call it f prime of x. Okay? So once again, we don't know what the actual function is, but we use this symbol to represent it. Vincent?
Don't you plug the f of x as 3?
I will in a second. I'm going step by step, but you're going ahead. Okay, we will. Just hold on. I'll be there in a sec. Okay? What's the derivative of g of x then? G prime of x. Yep. Good. Now, here's where Vincent says, hey, Mr. Lee, don't we plug in the numbers? Yes, we do. So what are we looking for here? We're looking for the derivative, and by the way, this should be y prime, not y prime. We're looking for the derivative at what value of x? 2. So that means wherever you see x, I want you to replace it with 2. So that means I want 8 times f prime of 2 minus g prime of 2. And then now, Vincent, I will do what you did and say, hey, what's f prime of 2? Ah, yes, f prime of 2. Look down the f prime column. Here's 2, so the answer is negative 3. So I'm going to ask us to do this. 8 times negative 3. And then we're going to subtract off of that g prime of 2. So what's g prime of 2? Negative 7. Excellent. So that's down this column here, this number. Okay. And then we'll ask you to simplify by doing the calculations. 8 times 3, that's negative 24. The two negatives together make it a positive, so I believe your derivative is just negative 17.
No, but
yes?
Can you just like plug it into the original equation?
No, because if I plug it into the original equation, you get number, and the derivative of the number is 0. So I can't do that. Okay, so you have to follow this idea using the function first, and then at the end plug in the numbers. Okay? All right. Let's try part B. Part B seems like we have a multiplication of two functions. Well, here's your A, here's your B.
Oh my god,
So,
are you serious?
no, don't worry, it's not that bad, not that bad. What's the jingle? Sorry, this is the rhythm, not jingle, rhythm. A, B prime plus A prime B. Good. So what's a in this case? That's just the function f of x. What's b prime? Well, b is g of x, so b prime is just g prime of x. Okay? Plus a prime. What's a prime? Well, a is f of x. A prime just means it's the derivative, so f prime of x. And b, of course, is just g of x. Okay, we're evaluating this derivative at 0. So I want f of 0 times g prime of 0, f prime of 0, g of 0. Now, go ahead in the table and now look for what you want. I want, first of all, f of 0. What's f of 0? What number is f of 0? 2. Good. 2. G prime of 0. Negative 10. Awesome. Keep going. F prime of 0. 6. Good. And then the last one is 8. Awesome. So 2 times negative 10, negative 20. 6 times 8 is 48. Add them together. 28. Cool. All right. You do the last one then. It's a quotient. Can you say low, d high, less high, d low, square the bottom, and here we go. Try on your own, okay? Low, d high. So what's low? Low is f of x. What's d of high in this case? What do we use? G prime of x. Good. Finish it off. Low, d high, less high, d low. Square the bottom, and here we go. Low, d high, less high, d low. Square the bottom, and here we go. F of 2, g prime of 2, minus g of 2, f prime of 2, f of 2 all squared. Go ahead and plug in the numbers. F of 2, what's that? G prime of 2. G of 2. F prime of 2. Can somebody check my work? I'm getting scared. F of 2. Negative 21 minus 15 over 9. 3 squared. Negative 4?
Yeah.
Yeah.